Alrighty, so this is homework chapter 16. This first one, I had to go look at the answer key and see the setup for it, just how you put in the point G and do everything based off of that. Once I got that drawing kind of down, then it was made more clear to me. Some of the forces is equal to ma, so the force is just p is equal to ma, and you can just solve for acceleration of 3.20 meters per second squared. And then to eliminate the vertical force, you just do sum of moment about b. It gets rid of fb. So you're able to solve for fa there, and then plug it back into the vertical equation to get force of B. So I get force of A is 3.819 newtons and force of B is 20.71 newtons. Question 2. Triangular weldment ABC is guided by 2 points that slide freely in parallel curved slots of radius 6 inches. Cut in a vertical plate. The weldment weighs 16 pounds and its mass center is located at point G. Knowing that at the instant shown, the velocity of each pin is 30 inches per second downward along the slots. Determine the acceleration of the weldment and the reactions at A and B. So the normal acceleration from the slot motion is v squared over r, which gets you to 12.5 feet per second squared. That's in the normal direction. And then the tangential acceleration from the net force. Because weldment is in pure translation, A and B accelerate equally. So sum of forces tangential direction is equal to mass times acceleration of tangential, getting you and solving for acceleration, you get 27.86 feet per second squared. And then coming up here, combining components for total acceleration. First part, we just did the direction of which way it's going to go using the inverse tan of the normal acceleration over the tangential acceleration. You get 24.14 degrees. That's from the slot direction towards the center of the circle. And because of that, you have to add on that 60 degrees. So total theta is 84.14 degrees. And then the magnitude of the accelerations is just the square root of tangential squared and normal squared. So you get the magnitude of acceleration is 30.56 feet per second squared at 84.14 degrees. Reaction at A and B. This is just mass times acceleration. This is 15.185 pounds, and you take the moment at A, and solving for B, we get 1.285 pounds. And coming over here, just sum forces in the x direction is equal to mass times acceleration. And we're able to solve this for the reaction at A is equal to 0.505 pounds. Question 3. Disc A has a mass of 6 kilograms, initial angular velocity of 360. Disc B has a mass of 3 kilograms and is initially at rest. The discs are brought together by applying a horizontal force of magnitude 20 newtons to the axle of disc A, knowing that coefficient of kinetic friction is 0.15 between the discs, and neglecting the bearing friction, determine the angular acceleration and the final angular velocity of each disc. So this is just what we're given. So the angular acceleration while slipping is based off the normal force from contact. So normal force is equal to that 20 Newton force. And so solving for the force of friction is just mu, which is the coefficient of friction, times that normal force, giving us 3 newtons as the force of friction. And then calculating I for each disk for A and B as shown. And then you apply moment equations for moment about A, moment about B, solving for alpha A and alpha B. And then finding angular velocities, you can relate the angular velocity of the A and B as shown. And plugging in our known values, we have to solve for T here. And then plug T back into our equations to solve for our PMs. So here we have 240 RPMs for A, and for B we have 320 RPMs. Question 4, a drum of 200 millimeter radius is attached to a disc of radius 140 millimeters. Disc and drum have combined mass of 5 kilograms, suspended by 2 cords. Knowing the acceleration of point B of the cord is 0. Tension at A is 40 newtons and tension B is 20 newtons. Determine the combined radius of gyration. So these are all the knowns. Because B is stationary, we can say the acceleration of B is 0. But we can relate the equation like so. So step 1 is vertical forces. Sum of forces in the y direction is equal to ma in the y direction. So tension at A plus tension at B minus weight is equal to may, solving for the acceleration in the y direction, and then using alpha, that alpha equation, plugging in our acceleration and getting our angular acceleration to be 10.95 radians per second squared. And then step 2 is just taking your moment about G. And so the moment for each A and B, and then is equal to I times alpha, which you could substitute as mk squared. And here we're just solving for k. So we get k to be 0.17095 meters. And then for problem 5, a uniform slender rod, length 900 millimeters and mass 4 kilograms, is suspended from a hinge at C. A horizontal force P of magnitude 75 newtons is applied at NB. Knowing that R is 225 millimeters, determine the angular acceleration of the rod and the components of the reaction at C. So, based off what we're given, we're going to start with a moment equation about C. Try to isolate our alpha variable. And so this is what we get for our alpha is 107.14 radians per second squared. And then the vertical reaction at C is just Cy minus weight is equal to 0. So Cy is equal to the weight, which is 39.2 newtons. And the horizontal reaction, you have mass and acceleration on the other side now. It's not equal to 0. So you just solve for Cx. You get to be a negative 21.4 newtons, so it'll be left. A wheel of radius r and centroidal axis or radial of gyration k is released from rest on the incline and rolls without sliding. Derive an expression for the acceleration in the center of the wheel in terms of r, k, beta, and g. So no slipping, so acceleration is r alpha. I is equal to mk squared again, moment at C. To get our alpha, and since A is R alpha, A is equal to R times what we got for alpha. And simplifying, we get our acceleration is equal to r squared over r squared plus k squared times g sine beta. Our masses cancel out, and that's what we're left with. For question 7, drum 4-inch radius attached to a disc of 8-inch radius. Disc and drum have combined weight of 10 pounds. Combined radius of gyration is 6 inches. Cord is attached and is pulled with a force P of 5 pounds. And then gives us the coefficient of static and kinetic friction. We're trying to find whether or not the disc slides and the angular acceleration of the disc and the acceleration of G. So step 1, we relate our acceleration to our R alpha, and then we take the moment at C to get our alpha, and then plug that back in to get our force, our max friction or just our friction force, which we get to be 1.6 pounds, and then calculating the max friction force by just using μs times the normal force, we get to be 1.25 pounds, and because the actual force exceeds the max friction force, the disc slides. And for our angular acceleration with sliding, we just use the moment equation to solve for alpha, and we get alpha is equal to 12.88 radians per second squared, and the acceleration of g is the translation, so force is equal to mass times acceleration. We have force, we have mass, and we can calculate acceleration from that to be 3.22 feet per second squared. And last but not least, question 8. I also kind of had to look at the diagram for where to take moments on. So I saw that there was a point E and point H at the bottom, which now makes sense of why those are there. So once I had that idea, it was pretty straightforward. So for disc A, moment at E, we're just basically coming up with 3 equations that we can use. Or we have a bunch of unknowns, so we come up with 3 equations and substitute in for each other to finally come up with our answer. So this is our equation involving C here. This is our equation involving D with disc B. And then our force balance, just relating everything together there. And then solving for C and D by themselves. And then plugging in and solving for the acceleration. Based off acceleration is equal to R alpha. We get our acceleration to be 2.6367 meters per second squared. And we get our force at D to be 11.86